In industrial environments, heat is not a comfort issue. It is a load that builds quietly, day after day. Factories adapt around heat until it begins to limit people, processes, and performance. At a manufacturing facility in Ras Al Khaimah, daily operations relied on ventilation, not air conditioning, to manage internal conditions. Fans circulated air across the factory floor, but the structure itself continued to absorb heat from above.
Fan helps move the air, but they do not stop the heat from entering the building. Most of the heat comes through the roof. This is where the thermal load builds first. So the question, it was never how to cool the air. It was how to reduce the thermal load on this building itself.
The approach focused on the building envelope. An electricity-free cooling membrane was applied across the roof surface, supported by a targeted wall treatment without altering factory operations. Installation was completed in 7 days from start to exit. Temperature measurements were recorded between noon and 5, the most thermally demanding hours of the day. These measurements are taken during winter conditions, when ambient temperatures was approximately 20 degrees Celsius. Alongside the recorded study data, live readings continue to be monitored on site, confirming consistent performance under current conditions. Even within this lower ambient range, the impact is clear. These results were recorded in winter. At normal operating temperatures of around 35 degrees Celsius, the internal surface temperature drop becomes even more noticeable. This reduction directly lowers the amount of heat entering the factory environment.
Beyond the heat reduction, the membrane also acts as a waterproofing layer. It protects the surface while reducing the solar, without compromising the structure.
By reducing thermal load at the source, the factory relies less on mechanical cooling to maintain workable conditions. Lower cooling demand translates into lower energy consumption, reduced emissions intensity, and improved operational efficiency without changing how the facility operates. Cooling does not always require more energy. Sometimes it requires better boundaries.